So there's a part two to this notes for 4.2. These are more growth and decay type problems, but the formula is going to look a little different. So it's actually a little bit simpler than compound interest. But it says in a lab experiment, 150 bacteria are placed in a petri dish. The conditions are such that the number of bacteria is able to double, that's a key word, double, every 24 hours. Write a function showing the number of bacteria after T hours, where the hourly growth rate can be found from a constant in the function. Round all coefficients in the function to 4 decimal places. Also, determine the percentage of growth per hour to the nearest hundredth of a percent. So here's how this works, okay? So we're going to start with f of t. F is the function, t is hours. Now it's going to look like this. So we're going to have a. Now since it says double, we're going to put 2 in the parentheses, okay, to the t over d power. Actually, let me write this a little bit better. Give us some room here. So f of t, okay, is a times 2 to the t over d power. Now t is the time in years. D is the doubling time. Okay? So A is the initial amount. So what's our initial amount? 150. So I have 150 times 2 to the t over, well, the doubling time is every 24 hours, so 24 goes on the bottom. All right? Now, I want this function to have just a t as the exponent, okay? So, if you remember from what we did in the last section, we can pull out 1 over 24. We can actually figure out what that is. So I have 150 times, now I have to calculate 2 to the 124th power. All right? And when I do that, I get 1.0293. Now remember, it said round to 4 decimal places. So I'm only going to use 4 decimal places here to the t power. Okay? Now, this is going to wind up being my function. Okay, so this is the first part of my answer. Okay? Now it says determine the percentage of growth. Well, the hourly rate, because it's in hours, is just 0.0293. It's just this part right here. Okay? So what that means is when I move it 2 to the right, that means I have a 2.93% increase, because it's growth, per hour. There's the second part of my answer. Okay? So when it's growth, it's actually it's a little bit simpler, but we're still using concepts that we used from 4.1. Okay? Let's look at a different type of problem. A person invested $940 in an account, growing at a rate, allowing the money to double every 7 years. Okay? So we need to write a function showing the amount of money in the account after t years. So f of t equals, now a is 940. So 940 times, we're doubling, so that's 2, to the t over 7 years it takes to double. So just like in the last problem, 940 times 2 to the 1/7 power. And then t on the outside. So I need to calculate 2 to the 1/7. So I get 940 times 1.1041 to the t. Now remember, you're going to get a lot more decimal places in your answer for this number in the parentheses, but you're only rounding to 4 decimal places. So there's our function. Now, it's years, okay? So instead of a monthly rate, it's a yearly rate. And again, it's just this number. So it's 0.1041. Well, if I move the decimal 2 to the right, that means I have a 10.41% increase. Now, it's per year, okay? It's per year, okay? Whereas in this problem, it was per hour. Here, it's per year. It's just you got to read the problem, okay? So there's the second part of our answer. So it's a different formula than the first four. All right, now, this actually has some real-life meaning to you. You have a new car. You got it for $21,000. And over time, its value depreciates, okay? Depreciates means decreases, okay? By 1/2 every 6 years. So it says write a function showing the value of the car after t years, okay? So everything else is the same. Now, so here's f of t. Our initial amount A is 21,000. Okay, but now it says 1/2. It doesn't say double. So that means my number in the parentheses is 1/2. To the t over, well, it says every 6 years. So 6 goes on the bottom. Now, pull all the numbers inside. Now, here's the thing, guys. If it were me in this situation, I would make 1/2 0.5. Okay? It's just going to make things a lot easier for you. 2, the 1/6 power. Then the t's on the outside. Okay? So we need to calculate 0.5 to the 1/6. And when I do that, I get 0.8909 to the t power. And again, I'm rounding to 4 decimal places. So you're going to get a ton of numbers in Desmos, okay? But you're only rounding to 4 decimal places. So here's our function, okay? Now, our yearly rate, okay? This number right here means decay. The first 2 problems we did were growth. So my yearly rate is 1 minus 0.8909, okay, which is 0.1091. If I move the decimal 2 to the right, I have a 10.91% decrease per year. Okay? So every year you have the car, the value of the car decreases by 10.91% in this situation. Okay? Last one. Element X is a radioactive isotope that every 18 years, its mass decreases by half. Given that the initial mass is 240 grams, and now it says all the same stuff. It says annual decay rate. So we're doing decay. So f of t equals 240 is the initial amount times 1/2, because there's the half, to the t over 18 years. Okay? So 240, again, change 1/2 to 0.5 to the 1/18th power to the t. So we need to calculate 0.5 to the 1/18th power. So if I do that, okay, remember I'm just rounding to 4 decimal places. I get 0.9622 to the t. So there's my function. Now, my yearly rate, since it's decay, is 1 minus 0.9622, which is the number in the parentheses. So I get 0.0378. Well, if I move it 2 to the right, I have a 3.78% decrease per year. Okay? So every 18 years. So it takes 18 years for that 240 to cut in half. But every year, it's a 3.78% decrease. Okay? So that's kind of part 2 of the notes for 4.2.